functions are like Rube Goldberg machines. You know this term, a Rube Goldberg machine? No? A little YouTube moment here. I'm sorry? Oh, no. I'm just gonna, well, maybe I can find it. Are there any of these? I actually just want to do one that I've seen before. But these are fantastic machines. So yeah. Let's do one that's a little bit more spectacular. So Rube Goldberg machines are machines that are supposed to be ironic commentaries on the most complex way to achieve a result through the most simple, or no, most complex way to achieve a very simple result. Right? So
you just destroyed your film by making it go through the X-ray machine. That's besides the point.
yep. Sailboats there. Oh. So this goes on for quite a while. I think you get the idea. So functions are like Rube Goldberg machines, but with code. They have stuff that you put in, like the pencil at the very beginning. They have stuff that, and there's tons of complexity potentially on the inside, like moving parts, code being executed, stuff moving around, like big actions, small actions. But in the end, it's usually something. In the end, it's usually something very simple that happens. So somebody packs their camera into a suitcase. So the ins and outs of the function might seem really simple, but inside you can potentially have something really complex, right? So functions, when it comes down to it, pretty much like that. Instead of just one input and one output, like one pencil, you could have several inputs. You could potentially have several outputs. For example, converting miles to kilometers. You input miles, you output kilometers. Super simple. You can create variables inside of them, and they are valid for inside that variable. It's a notion called scope, or inside that function rather. It's a notion called scope, and I'll explain what that means here in a second through demonstrating. So, what's a function? Let's say that we want to execute this line, hello, in multiple places. So, open up a fresh playground, and let's tackle this. And let's go through these examples one at a time. I think it's better just for you to do it rather than to talk to you or talk at you about it. All right. So what we're going to do first is just retype all of this. Functions are defined with a keyword, just like many things in Swift. That keyword is func. F-U-N-C. Functions have names. So this enables us to refer to the function in a very natural way. So just like variables have names, essentially, functions also have names. In general, we call those identifiers. So whenever you see that term identifier, all that means is being named for something. It can either be a variable or a function. So I'm going to write say hello. You'll notice a convention here that I'm using called a camel case, which is where I can combine words, and each word, except for the first one, uses a capital letter. syntax for functions, I need a pair of parentheses. And I'll explain the flexibility that provides later, but for now, let's just put parentheses there. So just like for loops in the word, there are parens available, and then braces. And inside those braces, I can write whatever I want. So I'm just going to write print line hello. There we go. All right, you just defined the function. This is called defining a function. Defining. So remember when we talked earlier about this notion of semantics? So in programming languages, we'll have a concept like variable. And we'll have things, operations attached to it. Variables can be declared, right, using var. They can be initialized using equal sign to give them an initial value. And they can be assigned later by using equal sign and giving it a subsequent value. For functions, we have two things that we can do. We can define it, which says, I'm going to tell Swift that this identifier, say hello, has meaning after this. And what that is this is almost like an alias. It's saying, say hello represents this block of code. Now I need a syntax that tells Swift when I want to execute that block of code. Just like if statements, like they have a condition that tells you that tells Swift when to execute that code, right? So if those conditions evaluate to true, it executes the code. For functions, we do this notion called calling. So we call a function, which tells Swift to execute the lines inside function's body or block. And that syntax looks like this. Say hello, and then two parens. Open and close. It says hello. Some of you actually might get hello down here, and I hope you do. This is super confusing. But when I'm talking about if statements, remember that sometimes I would use the word clause to talk about a block of code, like the true clause and the else clause, the if clause and the else clause, or an if-else clause. For functions, I refer to this with the word body. So this is the body of the function, everything inside the braces. Okay, did all of you try this? The say hello, open, close, and then did it do something up here? Do all of you get the hello up here and not down here? Alright, that sucks. But nevertheless,
Just a quick question. Sometimes open playground is import UI kit versus foundation.
Yeah.
Does that matter?
that doesn't matter. It's like UI kit is there because like you can't actually play around with UI and stuff. Like it's intended for you to be creating it inside the project. So I use foundation just out of habit. I just want to do Swift stuff. So it doesn't really matter. Okay. So that's that. If I write say hello again, then it says 2 times here. So I've actually executed that line, those lines twice in this case. So I'm executing over and over and over. If I write something like this, I'm executing this line of code under a certain condition, if someone's friendly. So if this is true, then this clause gets executed, this block of code. And inside, this function gets called. And when that function gets called, this body gets executed from the top down. I'm going to add a line to the body just to show you that multiple lines can show up here. We'll make this a little bit more readable by stretching this out. So sorry if you visually tuned to that. Okay, let me pause there for a moment so you can catch up. Let others ask questions if there are any questions. Any questions? Defining a function, use func. Calling a function with the identifier and a pair of parentheses. And that's it. There's as many lines as you want inside a function. It's pretty cool, right? No, it's actually pretty boring. It's kind of useless. Functions like this are somewhat useless because there are no inputs and no outputs to the function itself. All it's doing is printing stuff. I could put something really complicated in there, but every time I ran the function, it would do the same thing over and over again. Sometimes that's useful, but most of the time, it's not. In fact, the vast majority of the time, it's not useful. This is something where you might, write a function to ping a server, for example. And then if it has no data going in, no data going in, you're just executing a set of instructions over time, once every 60 seconds, or something like that, once every 10 seconds. And it might be useful. But this demonstrates the fundamental principles around functions, which I can do. The syntax for defining them, the syntax for calling them. Oops. So fundamentally, these are the two pieces I want you to pay attention to, func and say hello. Okay, so that's all fine and good. But what if I want to do more than that? What if I want to, okay, we already did this. What if I want to have an input to the function? Let's say I want to say hello, but I actually want to put a message, pick a person to say hello to. So in this case, what I'm doing is defining what's called a parameter of a function. So let me show you the whole slide. I can give a function a set of variables that are made available at the time a function is called, okay? Or whose values are made available at the time a function is called. So in this case, this syntax here, does this look familiar? I have an identifier and a colon and a type. It's the same exact syntax for declaring a variable or a constant with an explicit type. Make sense? I'm just missing var or let, so you don't need them here. In this case, what I want to do is define a variable that I can use in the body of the function, but defer setting its value to later, to what we call call time, which is here, when the function is called. So go ahead and type this out in your label. So func say hello, but instead of just having a blank space between the two parentheses, write the identifier name and colon and string. The same braces, and then some message. We'll use this interpolation syntax right here, which is sometimes really hard to read. Backslash, open, some expression, and then close. Whenever you hear me say open, close, it's always open parenthesis, close parenthesis. I'll rarely ever use open, close for braces or brackets. Okay. So open, close. Or paren instead of parenthesis, because parenthesis is what I say. So now when I call a function, if I were to use the same thing, well, this is not going to work. So you're going to have to comment out everything we wrote before. So playgrounds are a little bit weird. They have a little bit different behavior than what we would normally expect. So in this case, what I want you to do is use the /* syntax and comment out all of the code that we wrote before. All of this. So /* at the top, and then // at the bottom. So we'll just save that code for you. So now I have an error, missing argument for parameter number 1 in call. So, interesting error. What it's essentially telling me, we'll dive into this error in more detail a little bit later. What it's telling me is that this parameter doesn't have a value. I haven't given it something to work with. So, according to my example over here, I should write a string in that slot. So I'm going to write Toshi. This is hello Toshi. Okay. Variables. It can be declared. It can be initialized. Right? This is the equivalent of a variable declaration. This is the equivalent of a variable initialization at call time or at the call site. Benefit of this type of function is now I can say hello to anyone I want. Hello Toshi, hello Layla. Toshi was my dog, Layla was my sister's dog. By the way. Alright. So the flow looks like this. Swift looks up, say hello. Oh, it's a function. The very first thing that it gets in the parameter list, the list of parameters, this set of values inside these params at the call side, is a string. So what it does is it looks to see that there's a variable in that same slot. These are going to go parallel, 1 to 1. So Toshi is assigned or initializes the variable name. And now name is available in the body of the function as the value Toshi. Does that make sense? How all those terms kind of jumble and stack on top of each other? Yes?
I don't want to confuse anybody or myself. But if we declare var name equals a string, whatever that is, above the function, that would not, and we just printed say hello, would that work?
Right. So, no it wouldn't. So what he's asking is, oh sorry, but you didn't have this?
No, what you were doing was what I was thinking.
Okay.
Yeah.
So let me answer your question in a minute, okay? Because I think it's important to see. But I want to make sure that everyone relatively understands what's going on. So when this function is called again, and we give it Layla instead of Toshi, it comes around. This chunk of code gets executed again, but it has no memory at all that name ever equaled Toshi at all, ever, when it reaches here. So now all it thinks is that name is equal to Layla. Make sense? Make sense? Make sense? How much sense does it make? 5 if you get it, 4 if you sort of get it, feel like you sort of get it. 3 if it's 2 not really, 1 what the fudge is going on. Right? You don't have to hold that. We got a 5. We got a 4, 5. We have a hand. We got a 3. Give me a number. Fair. Okay, got it? Raj, you good? 4, 3, 2, 4. You're 4. Okay. I would call that pretty good. A pretty good understanding for first seeing a function with a single variable. Okay? Alright, what can we do to help? What can we do to put a little bit of understanding? Any questions? Yeah, do you have any questions? Your question.
If you're saying there's no recall of the Toshi, right?
Yes, no recall. And this,
But it printed.
that's right. Well, that's a function. Sorry,
But that's playground.
that's the playground.
But Swift doesn't remember the
That's
Toshi.
right. That's right. So if we imagine that this is just shorthand for print line hello Toshi, and this is just shorthand for print line hello Layla, then that's essentially what we're doing here. It's like this is just shorthand for inserting this chunk of code and then assigning all the variables to a value that I give. So anyway, any questions? Can you formulate a question in your mind yet? Just let them percolate, right?
But if it's like not gonna remember
Yes.
the history of the other one, is that relevant in
It is, oh, is it relevant? Is that fact relevant? Yes, it's relevant. It's relevant because I can have a function that does remember values from one call to the next. There's a way to do it. But because it's a parameter, the parameters are never remembered from call to call like this. Right? There are ways I can do it, but I haven't shown you how to do it. Okay. So let's do one more example using the same concepts, but I'll give two parameters to the function. Okay, two parameters to the function. So let me define a function called say. Func say. Open parenthesis. And so this will mimic the next slide. Actually, I'm not going to show you that just yet. I'm going to define a parameter called greeting, and I'll make it a string. But instead of using a closing parenthesis, I'll put a comma. Now I'm going to define a second parameter called name. And then I'll close the parenthesis and give it a body. Meaning, when I say give it a body, I mean print two braces. So now I'm going to say print line, and I'm going to do some similar interpolation where I do this weird syntax for both variables. So this is kind of a trivial example, but so greeting is going to be interpolated into this string using backslash open close. And then I'm going to do the same for name, which is backslash open close. I actually really hate that syntax. It's so hard to type for me. It's like, this is my hand.
what's that exclamation?
That's just an exclamation point. It's just part of the string. It's just going to print as an exclamation point. It's not syntax at all. It's just like,
Oh.
yeah. So now I'm going to call the function. So in this case, I have to give it two values. Something to say and someone to say it to. What's up? Let everyone catch up with typing. All y'all that can type like 90 words a minute, programming will totally suck. It might, but I would take that bet. So in this case, I have two parameters: this greeting and name. In the body of the function, they're called greeting and name. Those are the variable names that I chose. Each type is a string. So a string here, a string here. Which means when I call the function, the first variable that I give it must be a string. So the first argument that I give it. The second value that I give it must be a string. So it just assigns those variables one to one, like this. This gets assigned, what's up gets assigned to greeting, Toshi gets assigned to name. And it's the comma that separates those values. Okay? So I can continue down this path. All of these get printed. Is this starting to make more sense? Any degree? All we're doing is trying to take chunks of code and give them a name so we can use that chunk of code later. Cool. Last concept that I'm going to give you before we take a little break is how to get a value out of a function. So it's great to have a function that accepts values, that has variables that we can assign differently based on circumstances. But also, I sometimes need to get values out of them, like in the case of trying to compute something really complicated. Say I had an equation that would compute, one of the roots of a quadratic equation, for example. Remember that? Minus negative e plus or minus the square root of b squared minus 4ac all over 2a. Remember that gem? So that, in the mathematical sense, I think they call it an equation in math that you evaluate. But you can wrap it in a function. So in the programming world, we would call that a function. And its parameters would be a, b, and c. And we could call that function and compute one of the roots, or both of the roots, of that quadratic equation. Here, all I'm going to do is take the example that we did before, the kilometers to miles conversion, and wrap it in a function. But I want to go one step at a time, and just show you how to get a value out of a function first. So let's say I want to make a function that just adds two numbers together, right? Just about the simplest thing I can imagine. How would I start defining the function? I would start defining the function. Then I would choose an identifier, probably add. Alright, so I want to add two numbers together. Then, where would I start? What would I type next? If I want to write a function that adds two numbers together, what would I do?
Number one, string, number two.
It's certainly possible in the world of calling a function. I'm defining a function. So what comes after the opening paren when I define a function?
The first number.
No. You're close. You're so close. You're so close. Let me figure it out. A variable. That's right. So what variable should I choose? Just pick something. Number one is a value. The number one is a value, right? If I talk about one, that's a value that's an integer. But if I want a variable, what would I write?
First, no, like this.
Just the first number?
Yeah.
Like this?
Yeah.
Okay.
Yeah,
I kept hearing one. Oh, okay. I kept hearing one. I was like, totally off my game. I apologize. All right. Then what would I write?
Comma, second.
Sorry?
Comma, second number. Second number?
Okay.
Undefined type.
I'm sorry?
Undefined type.
Use of undeclared type second number. Yeah. That is an error message that doesn't help us at all. So what am I missing?
You want to say the type, so first number, colon, int, or I guess whatever we want to do.
Whatever we want.
Double.
Yeah, double's good, ints are good, whatever. And then so second number therefore should also have John.
Colon double.
Colon double. Excellent. All right. Okay, so here we go. This is the part that is different. So I'm going to use a new keyword now that tells Swift that I want to take a value and give it back to the context in which it was called. So that keyword is called return. And since I'm adding two numbers together, all I'm going to do is the first number plus second number. It's giving me an error. It's because I'm missing one thing. So whenever you create a function that does what we call return a value, computes something and then it takes that result and gives it back to whoever calls it, you have to tell it the type of the thing you're giving back. So Swift is a very type-driven language, strongly typed. So we have to have a syntax for telling it what type we're expecting to come out of here, so that Swift knows what to do with this function. So that syntax looks like this. Between the closing parenthesis and the opening brace, I want to write dash, greater than sign, so like a little arrow, and put the type of what comes out of here. What would that type be? Raj, any idea? A double. Like this. My arrow doesn't work. So now I have a properly defined function that adds two numbers together. The way I call it is like any other function. Okay. Does everybody have it typed out? Catching up? So the difference between what we did up here and what we're doing down here is up here we're using print line, and the playground is catching it for us and showing us those values in this little pop-out window. Here, add open 1, 1, 2. That's actually a value equal to 3. So that's something that's another value that we can do whatever we wanted to. We could assign it to a variable, we could pass it into another function, we could do anything. It's as if we had the number 3.0 sitting there instead of add 1, 2. Make sense? Let's call that function a couple more times, just to sort of try this to sink in a little bit. I have 8. So what I mean by that being a value is I can actually start to define functions like this. So I don't think I have anything meaningful to use here. So I'm going to declare a couple of variables that are somewhat badly named. All right. Speaking of things that are hard to type. Okay. If you look up for a moment, let's just read through the code and see what's going on. Starting at line 40. So, Aaron, if you had to describe what's happening at line 40 right there, how would you describe it?
Your 1 plus 1 is equal to, you're calling the function, so it's equal to whatever the output of the function is.
That's right. So, the value of that output is, the type of that output is double. Excellent. So, same thing is happening here. Yes. So, that means that whatever this value is, it's being treated like every other value that we've used on the right side of equal signs when we're talking about variables. So this value is going to equal 4, simply because when I call this function, the first number is going to equal 2, the second number equals 2, and then the result of that function, the value of what we call the return value, is equal to 2 plus 2, which is 4. Because I've assigned it to a variable, now I can use it in multiple contexts. But the point that I'm trying to show you is that Swift actually treats this whole thing as the result, as the value that comes out of executing this line. So whatever's just to the right of return becomes the value of the function call at the call site, meaning down here. Does that make sense? Kind of makes intuitive sense. It's like harder to describe than just to show you, actually. So, in any case, what I think I want to do, let's take a 6-minute break. We'll come back and we'll wrap that miles to kilometers to miles conversion in a function, so you can see how a practical example of how this actually works. Okay.